The new James Webb Space Telescope is barely settled in its new home in space, yet NASA is on to the next adventure for a worthy successor. Could the Luvoir mission be the key to opening complex locks of the universe? To answer this question, the agency has contributed a huge sum to finance the in-depth study of 4 scientific projects to better comprehend the risks and chances associated with each proposal. One such mission concept is the development of the Large Ultraviolet Optical Infrared Surveyor, popularly referred to as Luvoir. Putting it more appropriately, Luvoir is a next-generational, multi-wavelength telescope with promising prospects for space exploration. Would the Luvoir be the next major breakthrough to watch out for in the coming decades? Join us in today's video as we find out just that. Welcome to Posh Future. Don't forget to subscribe to this channel to get premium content on science and technology. If you're searching for the best telescope to solve the mystery of the vast and dark universe, there's only one telescope that fits into this description: the James Webb Space Telescope. From the discovery of habitable exoplanets to the uncovering of really crazy occurrences unfolding in space, JWST has proven its prowess as one revolutionary breakthrough in space observatories. But if you think you've seen it all with the JWST, then you should prepare your minds for the latest, most complex, and most ambitious telescope ever built. It's called the Large UV Optical Infrared Ray Surveyor, Luvoir. The good news is that we don't have to wait too long to begin enjoying this next-generational telescope. The development group behind Luvoir has slated a launch date for 2030. To understand this concept better, let's take a trip back to the time people started to wrap their minds around the mystique of space. For the past 32 years, NASA's Hubble has served us well with its high-performance technologies. If you pay close attention to its performance over the years, you'd agree that Hubble represents a significant milestone ever reached by the present civilization. Sadly, it also has its fair share of limitations. Hubble can't study wavelengths longer than 2 microns because it gets heated by the sun. As a matter of fact, the interior of Hubble is too warm to detect the mid and far infrared wavelength. Hubble's other shortcoming is confined lenses. Hubble can only detect an estimated 10% of the galaxies scattered across the universe. Most of these galaxies are combinations of too small and too faint. Remarkably, the James Webb, which was launched, addresses the issue of temperature, width, and can work with longer wavelengths than Hubble. On the 25th of December 2021, a new dawn broke out in space exploration when JWST successfully completed its launch into the universe. Most significantly, it would offer scientists first-hand scientific details that Hubble cannot. From the atmospheric conditions of nearby Earth-like planets to the earliest formation of stars, we can tell you things are starting to look interesting up there. The reason is JWST can study wavelengths out to 30 microns, and its massive sun shield and onboard active coolant would help regulate temperature. However, even with the powerful instruments embedded in Webb, most of the galaxies in space will remain evasive. In other words, most of the galaxies we observe would still remain a few pixels across with barely any clear structure. Most importantly, there would still be an absence of the high performance required from a telescope. The capability to directly picture Earth-sized planets around sun-like stars and to detect which one might turn out to be habitable. This conveniently brings us to one ultra-powerful telescope, developed to fulfill all of NASA's astrophysics growing needs in the next 3 decades, and that is the Luvoir. The Space Telescope includes ultra-modern equipment that will be positioned on the Earth's second Lagrangian point. This advanced telescope would be able to study ultraviolet, visible, and near-infrared wavelengths of light. To achieve this, the Luvoir research team are considering 2 models. One comes with a 15-meter mirror named Architecture Mirror A, and it will use a Space Launch System better known as SLS. The other model, Architecture B, comes with an 8-meter mirror across that could launch heavy-lift vehicles such as the Falcon 9. Impressively, the 15-meter mirror will be 50 times more massive than the heaviest Earth-based telescope. The Luvoir mission would pave way for outstanding improvement in notable scientific operations. From the period of reionization to galaxy formation and evolution, down to solar system remote sensing. The primary target of Luvoir is to distinguish a wide spectrum of exoplanets, including those that share Earth-like conditions, in other words, habitable. If the feat of Luvoir is eventually pulled off, it would help provide a thorough observation of exoplanets. Mind you, exoplanets share a striking likeness with the Earth in terms of size, mass, and orbit to Earth. Extrasolar planets are minute black shadows, not pale blue spots. A concept like Luvoir could switch that by gathering adequate evidence for scientists to begin observing these alleged exoplanets similar to Earth. It will be conducted in a statistical population-wide manner, similar to what the Kepler Space Telescope achieved with the exoplanets in January. It uncovered so many new worlds that paved way for scientists to begin comprehending the relative quantity of large planets orbiting very close to their stars in a small rocky terrain. Luvoir would concentrate on such tiny rocky terrains and reveal to scientists what percentage of planets seem to be Earth-like, possess surface water and atmospheres, and thriving organisms. Moreover, it will be able to discover the structure and formation of exoplanets' atmospheres and surfaces. It could also discover biosignatures produced by lives in the atmosphere of distant exoplanets. Biosignatures that have managed to capture the attention of scientists in their atmosphere include carbon dioxide, carbon monoxide, molecular oxygen, water, and ozone. Luvoir will not be transmitting images, but spectra break down the amount of light of different wavelengths emerging from each of the worlds under scrutiny. Thankfully, these spectra would enable scientists to discover the composite of that world, providing additional information about various occurrences unfolding on the surface. In a statement released by the Luvoir Group, if scientists could accomplish the feat of studying 28 small rocky terrains that turn out to have atmospheres containing no signs of existence, then they should be able to compete less than 10% of planets with the same size. Hopefully, if such a feat can be pulled off and life detected, scientists can progress to a more demanding task, like comprehending the laws of life. Sounds promising. Without a doubt, there is more than meets the eye of any form of existence. However, we may never know what they are until we have more examples of independent evolution. Therefore, the primary target of Luvoir would be to discover and observe distant planets and better comprehend the universality of life. Nonetheless, the telescope opens us to more distant worlds. In fact, observing exoplanets alone would not be adequate in making Luvoir a trailblazing mission concept. The Luvoir Group must also decide to make the telescope architectural concept important in order to appeal to different astrophysicist subviews. Consequently, the group had to refurbish the suggested instrument to be as workable as possible. The Mission Concept Group also developed about 12 sample science projects stretching across the scale of the universe to be included in the mission concept. Moreover, the group wanted to demonstrate the performance the telescope could pull off. From observing the dark matter and exhibiting how galaxies perform, to surveilling the icy moons in the outer solar systems for proof of water oozing out through their frozen shells. What's more, Luvoir would be able to study objects within the solar system greater than anything else. To prove a point, here are two distinct pictures gotten from Luvoir and Hubble. As you can see, the picture from Luvoir has superior quality to that of Hubble. Eventually, if NASA chooses Luvoir as its next generational telescope project, it will be born out of a long trail of innovations. Its predecessor, the Nancy Grace Roman Space Telescope, formerly dubbed the Wide View Infrared Surface Telescope WFIRST, was frequently called off under the Trump administration, only to be revisited by Congress. Another predecessor, the James Webb Space Telescope, is, far too expensive for maintenance and refueling purposes. Luvoir scientists and developers are converting the bittersweet experience with Webb into a file of 10 recommendations they believe will keep them right on track. As a matter of fact, not all of the blueprints are under the group's control. Some will be evaluated under NASA's policy. If NASA should improve the project, the Luvoir group believes the recommendation would assist them in escaping a similar fate as Webb. If you've enjoyed this video, don't forget to leave a comment behind and let's hear what you think about the Luvoir telescope. Till then, bye for now.